Cool. Who wants to see my research? So usually the play button's covered up. Yeah, I can't access the top right from my desktop. I've never used Zoom before, so that was fun. Cool.
It's called Zoom because it's hard.
We're in too close. Okay. So, hi, my name is Ryan. Yes, I work at Cloudflare. This is a fantastic audience. I hope you're all excited. Gophercon is going to be fun. Someone's pointing up, so I assume my microphone isn't loud enough. I'm going to try and speak loud, though. Okay, so I'm going to talk about idiomatic design patterns in Go. But before I do, I want to paraphrase this man here, who I didn't actually realize was going to be emceeing tonight when I wrote this. So sorry, Dave, if I got it wrong. But talk less about frameworks, talk more about design was the gist of the message, to paraphrase. And I think what that means is, there is a lot of content, a lot of discussion around which framework do I use, which library do I use, how do I optimize this, 57th router framework. And it's great discussion, but there's an appreciation for design that I think historically, out of kind of the object-oriented programming world, there was a lot of discussion about it. Kind of pendulum swung too far, some might say. But my goal of this talk is to get you to think about how you design your code and try to encourage you to talk about the design of your code as well. And I don't want to put everyone to sleep by talking about books, so I'm going to try and take the best bits that I've learned from the bits that I've read. But these are 3 great books that talk about design of code, and I highly encourage everyone to read them if you haven't read them already. So Design Patterns, quite an old book. The 4 authors are sometimes referred to as the Gang of 4. This references 23 design patterns, and we'll cover those in detail, in some detail. The Agile Software Development book by Robert Martin. So this book covers a lot more than the design of software, but it does speak specifically to the solid principles, if anyone's familiar with those, and domain-driven design, which talks about kind of one of the things that I think I've seen used most successfully in Go projects at Cloudflare is the repository pattern. So I'm going to talk a bit about that. So before anyone gets their pitchforks out and says, that's not idiomatic, I want to just clarify that by using this word in the title, I hope to frame the conversation around design patterns and thinking about how you're going to implement them in Go. One should try to strive for doing it, following best practices and considering best practices in mind. And these kind of 4 resources are my favorites for referring to people when they try to understand what does idiomatic mean. This term gets used a lot in our community. I think that particularly Effective Go and the Go Code Review Comments resource, they cover a lot of those really detailed things that talk about, how to call something, should you accept an interface, return an interface, those kind of things. And the Go proverbs, which this links to. And by the way, the slides I'll put on Twitter after my talk, and there's links to code examples and things like that, including these links. The other thing is design patterns. This is somewhat an ambiguous term for some people, so I thought I'd try to clarify it. I copied it from Wikipedia, though, which is a ridiculous thing to reference, but here we go. So reusable solutions to commonly occurring problems within a given context, right? So it's recognizing the same design you might apply in multiple, different domains, but it's within the same context of design. That's what we're talking about here. So the Design Patterns book, one of the first that I showed, covered 23 classic design patterns, and it categorized them into 3 kind of groups. Creational, which relates to how you essentially create a value or instantiate a value. Structural, which relates to the composition, composition of behavior and also composition of code. And obviously in the object-oriented traditional landscape, That meant, I think, more specific things. How we do composition in Go is different. And then behavioral, which relates more to communication and how, I guess, your code acts because of the way that it communicates, is the best I can try to translate it. And so part of what I'm trying to achieve in this talk as well is these concepts talk a lot about Java or C#. And when you're reading the content, it's really hard to kind of map back to how do I do that in Go. So I'm going to give some examples that I put together of the factory pattern, the decorator pattern, and the iterator pattern in Go. And some of these examples, I will try to call out whether I think it's an idiomatic thing. But I tried to write, particularly, I think the decorator pattern can get pretty interesting. But first, so the factory pattern, has anyone used this before? Cool. All right. So hopefully you'll learn something, but probably not because almost everyone's used it, which is great. So you're initializing a value. This is interesting because, there's, I think, a proverb that says accept interfaces return values, but in the factory pattern, you're likely to be returning an interface, and that's just the mechanism that is the factory pattern. So this is sometimes referred to as the factory method pattern or the abstract factory pattern. An abstract factory is essentially a set of methods that are factories, is the easiest way to distill that. So some actual Go code. So essentially what you're talking about is you're passing in something that describes what you're looking for, and you're getting back something that implements an interface. And I've seen this done using an iota. I've seen this done using strings. You can have various kind of ways to pass that value in. And this is a very simplified example, and I'll show its usage on the next slide. But this is just an example where it's an IO writer. You tell it whether you want some custom writer or you want to use standard error. I think the code kind of speaks for itself. It's a very simple example. So looking at its usage, we've got a simple main function that accepts input when you execute the command, and it loads the writer based on that input, and then you write. This is pretty straightforward, but I guess the first time I came across this pattern, it was in a web app, and there was a couple of login buttons from different social providers, and you click a button that was a query parameter in the next URL, and that query parameter filtered down to a factory pattern that instantiated your API client library, and that was how I was using it, and I found that quite useful. So the second is the decorator pattern. So this is an example of a structural pattern. And I find this particularly interesting. I don't know if anyone's used GoKit. Maybe show of hands who's used GoKit. Okay, that's a decent amount of people. So GoKit is one of my favorite kits for building microservices. And one of the things that it has as a kind of core feature is the use of what's called middleware, which is using the decorator pattern, right? So what it allows you to do is you can implement an endpoint and you can add functionality to it, and you don't have to modify your original endpoint. For example, if I implement an endpoint that handles a HTTP request and I want to add logging to that endpoint, you can wrap it with a decorator, and the decorator handles that logging. And so that's the example that I'm about to show. It's the same kind of concept, but using Go primitives. And why is this useful? For those familiar with the single responsibility principle, which is outlined in the second book that I listed, the idea is that you're separating concerns and having a single responsibility of your code. And the idea of that is that a change to a behavior should not impact, there should not be multiple reasons that a behavior can change your code. Right? You want one change in behavior to impact your code, and a different change in behavior should essentially affect a different part of your code. That helps with modularity, it helps with code development, supposedly making your code more robust. So in this code example, we have a very basic web server. We don't handle errors because they're code examples, but you should handle errors. And you could probably do a better job of launching a web server as well. But yeah, this is a very simple endpoint, right? It's your hello world endpoint. So we take that HTTP handler func, and if we want to, we can implement a decorator pattern that does logging. And what it's going to do is log the request method and the request URL as we make that request to the logged endpoint. So as you can see, we haven't actually modified our original handler, but we're able to add behaviors to it. And this is great when it's across modules. You know, you might be able to import a set of decorators, and you know, you can reuse your underlying code libraries across multiple applications. So it's fantastic for that. And we use this a lot, particularly because GoKit encourages it. So the iterator pattern, you can actually see this in use throughout the Go standard library. So if you look at IO Reader or the SQL database row, you can, I think it's scan is the method that you use for row to load data out. And there's a next method and an error method. With IO Reader, you know, it's the read method, which reads the next kind of iteration, right? And you can implement this yourself. And kind of people have talked about, well, why don't I return channels from my methods and just read data out that way? There are various reasons. You know, you don't want to couple your code to the underlying behavior. So if you've got code and you're using an iterator pattern, for example, you don't have to implement it with concurrency. But later on, you can come without changing the interface and implement the concurrency. So let's take a look at some code. This is another basic example. So you define a type that has, you know, a set of tasks, and you keep note internally of the state of the position. So it's important to note that the iterators hold state of their current position, right? And iterators, they can be sequential, but they don't need to be, you know, like the order is an implementation detail. So if you're navigating different data structures, you can do it using different means. You can go forward and backwards. So yeah, we're just moving positions, incrementing as each call to next, and we're returning the current position and the task at hand, which is just a string. Also, something that you might have, if you're familiar with the IO library, there's a EOF or end of file, you know, variable. Similar to that, we've got a domain-specific version of that where it's indicating end of file. So it's a way of gracefully indicating that you've finished the iteration. Right, so when you use this, you can actually, you do a loop, you keep calling for the next entry, the next task. You want to check for that, you know, graceful end of file. And that could quite easily be, we could reuse the IO end of file type if we wanted to for this, but I just chose to use a custom one. And yeah, we can log if there's an unknown error, print a list of tasks. That's another pretty basic example. So that were the kind of three main design patterns from the very traditional 23. That's just a sample from each of the types. And I want to get into the next bit, but does anyone have any questions on those three patterns that I've covered so far? Yeah?
Pick those because they were easy to show us, or pick them?
Yeah, probably because they were easy. I'm not going to lie. But it's, to be fair, it's one of those things that I think they're the most applicable. Yeah, it's like if you can find an example in the standard library where you're like, this is, you know, demonstrating that pattern, it goes to show, you know, how useful it is in that language. And there's certainly, of those 23, if you go through them, there are some that are like so strictly tied to the notion of object-oriented programming, and, you know, the fact that, you know, implements an interface is a tight coupling and all those kind of things, that they don't make sense in Go. But I would encourage you to go check all of them out. It's very interesting as a thought exercise, you know, to go through those. Any other questions? Cool. Okay, so who here has heard of inversion of control? Yeah. Okay. This is like a really old concept that predates the dependency inversion principle. But I actually tried to put together a slide on inversion of control. And then through reading, you know, about this principle and thinking about it pretty hard, I think the intent of defining dependency inversion principle was that it was a much crisper definition of what was trying to be achieved. And inversion of control is a much broader concept. And it's pretty interesting to read various threads on the internet about people arguing over the two terms. Like, get back to work and write something useful. So anyway, the dependency inversion principle is kind of these two statements, and it talks about modules and abstractions. You might think of this as packages and interfaces in Go. And it's that, you should think about your code in layers, helps to make it modular, helps to, co-develop things on the same project, those kind of things. And you don't want your high-level modules, coupled to or tightly coupled to the low-level modules, right? If you're accessing a database, you don't want your domain logic tightly coupled to the database that you're using, for example. And I think that's generally well understood about this principle. The second part, I think, is a little bit less clear. There's like one paragraph that's really good in this book that digs into the details of it, that abstraction should not depend on details. I think it's basically stating that a good abstraction is such that you can change the underlying mechanism without having to change the abstraction, but accepting the fact that over time, it is likely that your abstraction will change. It's definitely a really great thing to talk about in theory, but we all know theory and practice are very different things. So in terms of these are slightly simplified versions of what's in the book, but explaining this with graphs because, yay, graphs. The client layer depends on the service layer. That's kind of the naive way to implement it. And when you're just quickly, building something out as a proof of concept, you might do this, and that's fine. But over time, to make a complex application, what you want to do is you want your client layer coupled tightly to an interface and not the implementation. And then you can have that implementation and you can swap it out. And that's the idea of dependency inversion principle, is that instead of this arrow to the service layer going down, you're inverting it, you're flipping it, and it's dependent on that interface. So dependency injection, I've been using this for a long time, and someone asked me a few months ago why I even use dependency injection. It was less obvious to me that this is something to talk about, but I think it's really good to talk about it. So there's a lot of kind of theory around this, but essentially you're passing the service to the client, and this is just like reiterating what I've just shown you with the graphs. But this is a concrete way to implement dependency inversion principle. So there are three kind of styles that are outlined in the second book that I've mentioned: the constructor, the setter, and the interface style. I think the interface style, it's a perfect example of something that, if you look at the material and you say, how does this translate to Go? Well, the way interfaces are designed in Go, I think it makes it less relevant, right? You could try and do it, and you'd end up, I actually tried to write the code, and I ended up with like 30 lines, and I'm like, where's the value? This doesn't make sense. So yeah, I'm going to talk about the constructor and the setter method and kind of the pros and cons. So here's an example of the constructor style where constructors, which is, arguably you shouldn't use a constructor unless you have a good reason to use it. You should rely on zero values, but there are times where you do need that. So you pass your dependencies in explicitly when you call that constructor. So new my service, that's terribly named. So yeah, you pass it in. I apologize. Examples are hard. Naming things are harder. Yeah, so you pass your dependency in. It's explicit. You can store that state in your struct, and then when you have a method that depends on that, you make a call to that. So, for example, write hello. We're calling s.writer. S.writer is an IO writer. We pass that in as a dependency, and how that is implemented is completely up to that dependency. So I can easily swap that out for any kind of implementation I want. The setter pattern is almost exactly the same thing, except in this example, instead of specifying the dependency when I'm using my constructor, and I might not even use a constructor, I might just have a struct, right? I have a method on that type called setWriter, and it allows me to set it later. So some of the reasons why you might do this is if you want to construct your dependency later on in your program, or if you want to change it. And this is where I think the line gets really tricky with Go. you know, people will argue that it's dangerous to potentially have a nil dependency and your program will crash, and that's a valid argument. And that's the reason I think why people use constructors instead of relying on MP values, right? So, you know, my gut tells me that using constructor is the easier thing to use. You can enforce valid dependencies, whereas using the setter, if I needed to allow creation at a later date, maybe I'd use this pattern. There's actually a couple of other design patterns that you could use as well that would arguably do a better job that can defer instantiation. But you could also use both, and I think that's interesting, right? You can pass it in when you construct, but you can also offer a method for changing it later. The thing to be conscious of is that a dependency, if you're tracking state, you can cause havoc, right? Because if you have two different implementations and one already has a certain state and you're throwing it away for another, you know, you've got to consider, like, how do I do a state transfer or something like that? So I'd probably just use constructor. In fact, I would happily say that all of the code that my team's written has just used constructors, and I think this is largely because GoKit is a thing we use largely, and that's encouraged within GoKit. So does anyone have any questions about dependency injection? Anyone want to challenge my assumptions about interfaces being a bad thing because of Go? No, cool, you're such a lovely crowd. This is great. Unfortunately, I find myself writing less code than I used to, so no. But if I was writing more code, it's a good question. I don't know. Yeah. I think usually the majority of the time I would stick with the things that, like, GoKit is encouraging. Like, there are two main things that I've historically worked on is a microservice. It's essentially a HTTP REST service or like a Kafka consumer. So they're pretty straightforward use cases.
I'm not familiar with the interface. So, like, what makes it not friendly?
So this is specifically a style of dependency injection called interface, which isn't confusing at all. Yeah, no. So essentially, it's kind of like the setter method or style, where you have a setter method. But instead you define an interface to the thing that has the setter method, and then you give the thing that has knowledge about how to instantiate the dependency, you give that the implementation of the interface. So it's like an extra layer of decoupling that's a lot of indirection, and I don't know if anyone got time for that, but that was a terrible pop culture reference, sorry. Cool. So domain-driven design. This is a really great book. This is actually a much newer book. Newer, it's still like mid-2000s. So the premise of this book is that projects should focus on domain, right? A large amount of, like, business value is derived when you focus on your domain and combining the kind of primitives that your language or, you know, kit or framework or whatever you're using has. You combine those to be utilized in your domain and deliver business value. And I think that that's the crux of, you know, what this book is talking about, is how do we build our applications so that we're focusing on the domain. How do we build it so that the design decisions that we're making, we're thinking about the domain today and how it might evolve, and also to kind of initiate that collaboration between the people kind of building the software and the people that are domain experts, particularly in larger companies. You know, the domain experts, you know, could be a product manager, could be a different person to the person actually writing the code, and by modeling your software around the domain, you tend to have better outcomes, you know, long term and for larger projects. And this isn't the way that you have to do it, right? It's just a way that you should think about doing it. And I highly encourage you to read the book. An example of my favorite thing from this book is the repository pattern, right? So one of the first things when I came to actually writing production code in Go that I had to figure out was, how am I going to connect to a database in a way that makes sense? You know, I've come from other languages where there's been ORMs for years and various ways of connecting to databases. People have had the whole argument about why you should or should not use an ORM. that's very easy when you're in another language, but in Go, I really do appreciate the design of, say, the Postgres PQ library, and how good it is until you end up with thousands of HTTP threads concurrently trying to call your database. But that's another problem. But how do you write your code so that you can evolve it over time? And if you think about this is a really great way to think about how to design your code and structure it. So the TLDR of this is that you want to abstract the persistence and retrieval from your business logic. Another great diagram. Could have used more colors. So package main calls out, like you want to couple it to a repository interface. And you can actually put this in the same package. You can put it in a separate package. Historically, the way I've seen it easiest to like reason about is if it's in its own dedicated package where your domain is defined with domain types, repository, whatever else you have. That's a pretty contentious topic, I think, about structuring applications and whether you should have a domain package. But for the purposes of this book, I think it's pretty clear that it should end up in a domain package. And then you can have a separate implementation in a separate package, which implements that interface. And you can actually have, say, multiple domains implemented, or multiple repositories from different domains implemented by one package. It can be Postgres, you can have in-memory, that kind of thing. So an example of code, this spans across 3 slides. It's really hard, apparently, to put source code onto slides, so I apologize. But this is the first of 3. So above that bottom comment, that top section there, that is one package, right? That is the kind of domain package that I talked about. We're calling it project. It just has one entity, project. There's a bit of stutter there. I should have named things better. But yeah, project is a type, pretty simple ID and a name. The repository has some very basic methods. You can get everything, which is going to be great for the memory of your program. You can store, which does, it's an upsert, right? You can insert, you can update, and there's the delete. And then below that second comment, the package immem, this is the start of the package. So first of all, we've defined a type that holds the implementation of that repository. Right, and it's just going to be an in-memory thing. So it's literally holding a map of IDs to strings. A simple example. We're also storing the highest ID, so we can generate, auto-increment a new ID as if we're a fancy database. And I've just picked one of these kind of examples. There's a more extensive example online. I threw it up on GitHub for anyone that's interested. But here's an example of store. It's pretty basic. So make sure that our map exists as a thing, so we don't run into memory issues. Checks if we're doing an insert or an update. If we're doing an insert, we're incrementing our ID counter and we're assigning the new increment to this new entry. Otherwise, we're checking that the entry does exist. If you're going to specify an ID in the project that you're giving me, it needs to exist. Otherwise, I'm going to throw an error. And then I update my in-memory representation and I return the new object. So the new object, obviously, if I've generated an ID, will now contain that ID. So an example of this in use, we instantiate the project repository. We decide to store a project. We're going to get back new project, which has the ID on it. We can then update the name. We can then decide to store it again. Once again, I've omitted error handling and all those good things. But the interesting thing when you look at this example, based on all of the things that I've just talked about, if you use dependency injection in this example, your project repository, it could be this code where we're doing storing and we can do deletion. Yes. Oh, 5 minutes. Cool. We need to figure out a new symbol for 5. 4 minutes. Beautiful. Perfect. That's all right. So if this code is buried deep in your services where your business logic is, so you're storing and updating and deleting and that kind of thing, you can inject the implementation, being Postgres or InMem, into those services, which makes testing far easier. You can write tests against a stubbed or completely mocked or whatever word you choose thing. You can test against that. Martin Fowler has a really great blog post about which phrase to use. I can never remember which phrase to use. Let's call it a fake. So that's everything I had to talk about. It's probably in 2 minutes, which is peace. But yeah, I hope everyone didn't fall asleep thinking about books too much. They tend to put me to sleep in a good way. But those 3 books are really great. I definitely am not going to say that I've read them end to end. So if you pick out a particular detail about them, I might not know it. That's okay. But they're really good stimulus for thinking about design. And I hope that everyone will walk away from tonight thinking more about the design of their code and how they're going to evolve their business applications over time. And if you want to talk to me about it, I'd love to chat about it. I love this stuff. If you have any questions about Cloudflare, or if you want to grab sticker, we launched a public DNS resolver, so we got some 1111 stickers. Would have been easier if it was 1, 2, 3, 4. Sorry? I have colorful ones. I don't know where they are, but if you want to see a colorful Cloudflare sticker, and we have Gopher stickers, they're really cool. So come grab one. Yeah, any questions? Yeah.
Before we answer that, is Vasco in the room? Do you want to come up and we'll get you mic'd up?
So the question was, what are we doing for onboarding people in addition to those things? So I've actually changed into a new team that's focusing on developer productivity. So I'm exactly the right person to ask, but I'm also like just off my last team, so I'm not quite prepared with a great answer for that. But I would say we have a lot of frequent kind of discussions. We have a thing called Ends Presents, where every week we do a rotational between our offices where people get up and we'll talk about particular topics that are of interest. And that's super handy. We have Engineering Bootcamp, which provides training, how to get up and running on our Kubernetes cluster, those kind of things. So yeah, we try to disseminate the information that way. Plus there's like, a lot of good code review and all that good stuff that goes on. Hope that was a good answer. Jade. Oh, yeah. Yeah, there's a thing called Go Hack Night that I actually run at the office. Hopefully every month, except for when I'm at Gophercon. The rest of the office can just read the live blog posts, right? There we go. Yeah, so that's a lot of fun. People show up, bring their laptops, do talks, hack on things. Yeah. All right. Thank you.
Thank you, Ryan. Is Kevin around? We need you to help us get the projector set up. So, thank you, Ryan. That was awesome. I'm a big fan of those books written in the 90s that no one reads anymore because they're not available as ebooks, but I think they're a super important resource. So thank you very much.
Yeah.
Yeah.